Hello class, welcome to our review of Chapter 8. We will be going over factoring and how to solve problems. Specifically, we'll be dealing primarily with factoring trinomials, but also factoring polynomials that have four terms using a method called grouping. So before we begin, we'd like to review the FOIL method. First, we want to learn how to multiply polynomials together, and the method we use is called FOIL. So if you have an expression that looks like this, a plus b, and you're going to multiply that by c plus d, then you want to do the first terms plus the outer terms plus the inner terms plus the last terms, FOIL. So the first terms will be these two right here, a and c. A and c. The first in each of the binomials, we call that the first terms. So a times c, you multiply those together. Then you do the outer terms. The outer terms is a and d, and then b and c will be the inner terms. So the outer will be a times d plus the inner, which is b times c, plus the last terms will be b times d. The last terms here, b and d. So first, outer, inner, last. So this is how we multiply two binomials together. We will use this a lot, not only for multiplication, but when we do the reverse of that, in factoring, this will be very important to know. The next thing we want to cover is special products. Special products are special cases of multiplying two binomials together. So we call this special products, like so. And there are some common ones that we'd like to review you on. You should remember these, but just in case, a plus b quantity squared. A plus b quantity squared multiplies out in an interesting way. First of all, a plus b quantity squared is a plus b times a plus b. And if you were to multiply this using the rule above, first, outer, inner, last, you would get a squared, that's first, plus outer, ab, plus inner, ba, or it's also ab. Remember, you can multiply in any order. B times a is the same as a times b. So we will do it in the same order as the one just before it, plus the last term. Last term is multiplied is b squared. So notice that this works out to be a squared plus 2ab plus b squared. A squared plus 2ab plus b squared. Okay, that's the rule right there. A plus b quantity squared is like this. The next one is almost the same, except it's a minus b quantity squared, which is a minus b times a minus b, which equals a squared minus 2ab plus b squared. I'm not going to go through the steps there, but it's minus ab, and minus ab is minus 2ab. Outer and inner gives minus 2ab. And of course, negative b times negative b is positive b squared. Then the last one that we're going to review here is what we call the difference of two squares. If you have a squared minus b squared, how does that look anyway? A squared minus b squared. Well, it factors in an unusual way. It is a plus b times a minus b. Okay, difference of two squares is a plus b times a minus b. So how would that look? First is a times a a squared, outer minus ab, inner is plus ab, and then last was minus b squared. Notice now that these center two terms cancel each other out right here. Zap, gone. And that is then just a squared minus b squared. So a squared minus b squared is a plus b times a minus b. Well, that concludes our review of special products. And now we will go on to some examples. Okay, some examples. The first example I would like to work for you is just a simple multiplication problem and solving for x. So example number 1. If we have 2x times the quantity x plus 3, and we wish to multiply that by 2x times x plus 3, and if that is equal to 2 times x squared plus 3, then solve this for x. Well, just use your distributive property. 2x times x is 2x squared, plus 2x times 3 is 6x. And that will be equal to 2 times x squared is 2x squared, plus 2 times 3 is 6. Now notice here on the left and the right we have 2x squared. On the left 2x squared, on the right 2x squared. If I subtract 2x squared from both the left and the right, they will cancel out. Okay? So I'm left with 6x is equal to 6. 6x equals 6. And of course, if you divide both sides by 6, you'll see that x equals 1. So there's your answer for example number 1. We now move to example number 2. Example number 2. Example number 2 is multiplying two binomials together, 2x plus 5 times the quantity 5x plus 2. Again, we just use FOIL. First plus outer plus inner plus last. Our first terms, 2x times 5x, is 10x squared. Plus the outer terms, 2x times 2 is 4x. Plus the inner, that's 5 times 5x, or 25x. Plus the last terms, 2 times 5 is 10. So this simplifies down then to 10x squared plus 29x plus 10. Okay. So that's just a simple multiplication of two binomials together. And now we move to example number 3. Example 3 is taking the rule a minus b times a minus b, where a minus b quantity squared. Remember, it's a squared minus 2ab plus b squared. So our example here is x minus 7 quantity squared. Now if we follow that through, it will be a squared. The a term here is x. So that will be x squared minus 2ab. 2 times x times 7 is 14x. So it's minus 14x plus b squared, which is negative 7 squared, is 49. So that's our answer. However, if you wanted to prove that, all you have to do is say x minus 7 times x minus 7, and you do first outer inner last. X times x is x squared minus 7x, that's the outer, and then the inner is also minus 7x, and then the last plus 49. And you can see then that these center two come together to give minus 14x. Okay. That is example number 3. We now move to example number 4. Example number 4 is simply to see if you can factor out the greatest common factor from a trinomial. So here we have 8xy, and we are subtracting 16x cubed y, and then we add 10y to that. So when you look at this expression, this trinomial here, you see that there's 8, 16, and 10. What's the greatest common factor between 8, 16, and 10? You see that 2 goes into each of these. 2 into here 5, 2 into here 8, 2 into here 4. So we can factor that 2 out front. However, there's also a y in all of them. One power of y here, one here, and one here. So we can factor out 2y. 2y times the quantity 4x minus 8x cubed plus 5. So we factored out the greatest common factor, which is 2y. Not too hard. I think you guys can do that without difficulty. Example number 5. Example number 5 gets just a little more exciting. This one is factoring by grouping. So let's write this down. 2x squared minus 3xz minus 2xy plus 3yz. Okay. So here we have a polynomial with 4 terms. And we look at this and we say, well, what goes with what? Can we use factoring by grouping here to bring this into the product of 2 binomials, perhaps? Let's see. So we notice there's an x here and an x here. There's no z in these terms, but we have z in both of these. So we see the z in both of these, the x in both of these. So perhaps if we group them as follows, we could consider this one together with this one, and then we consider this one with this one. So we'll group them in that order. So I'm going to rewrite this in that order. So it's going to be 2x squared minus 2xy minus 3xz, okay, plus 3yz. Now notice here that these are exactly the same. I haven't changed anything except for the order. Other than that, it's exactly what it was. Now, you look at the first two and you say, I can factor the greatest common factor out of these two, which happens to be 2x. So let's factor out a 2x. Let's say 2x times x, 2x times x is 2x squared, minus 2x times what gives 2xy? just y. So 2x times x minus y. Okay. Minus, we subtract now, that's this subtract right here. Okay. Subtract what? We can factor a 3z out of both of these terms. Notice 3xz, 3yz. The greatest common factor between these two terms is 3z. So let's factor out 3z. And if I take 3z and I multiply by x, I get 3xz. Now the trick is I'm subtracting. Notice that if I'm going to subtract 3z times something, and it comes up to be plus 3yz, notice this is a positive, it's addition, adding 3yz, I have to have a minus sign here, because a minus times a minus will be a plus. Okay, again, a minus times another minus, a negative times a negative will be a positive. So this is a bit of a trick. When you factor out something like this, and you're going to have parentheses, if this is going to be positive, then it's a negative times a negative. So 3z times y. 3z times y. Notice here now we have common term of x minus y. Common term here of x minus y. These are the same, and we can proceed with that. So I can bring my x minus y out front. That's the common term. Factor it out, bring it out front. X minus y times 2x. So I put my 2x. Subtract x minus y times 3z. So there's your answer. Factor x minus y times 2x minus 3z. We'll now move to another example that helps us to understand this whole concept of factoring by grouping. Factoring by grouping. Okay, I've lost my place here for a second. Hang on. Where is this problem? Okay, I've found the problem here. So this will be now example number 6. And again, this is another factoring by grouping. So here's the problem. 24 AM minus 9 AN plus 40 BM minus 15 BN. So there's the problem. And you look at this and you say, well, what can we group with what here? We see we have an A and an M, an A and an N. Both of these have an A. Okay? Neither one of these have an A, but both of these have a B. So if I consider them as follows, then I can factor something out, the greatest common factor. Notice 24 divides by 3, so does 9. Over here, 40 divides by 5, and so does 15. So let's factor out what we can factor out. A 3 out front here. 3 times A. 3A times what? 3A times 8M. Okay? Minus 3A times 3N. Plus, now we factor a 5B out of here. 5B times 5 times 8 is 40. So 8m, and 5 times 3n here, 5b times 3n is 15bn. So now observe here that these two terms each are the same. We have a b minus 8m minus 3n right here, and we also have 8m minus 3n here. So we factor this out front, bring it out front, all right, 8m minus 3n, and we will multiply this now by 3a plus 5b. Okay? 3a plus 5b multiplying 8m minus 3n. And that is example number 6. Now example number 7 takes us to a new level here. We're going to start solving for x by setting equal to 0. So example number 7. So let's take the equation 3x squared equals 5x. And let's solve this for x. To solve for x, we will bring the 5x over here to the left. And when we subtract 5x from the right side and the left side, we will be left with 0 on the right. So this will become 3x squared minus 5x equals 0. Now when you look at this, you see here that we have a common term, common factor I should say. The greatest common factor between these two terms is x. So I factor x out like this. X times 3x. What's x times 3x? X times 3x is 3x squared minus x times 5 minus 5 here. So x times 5 is minus 5x. This is equal to 0. Now you recall that if you have a product of two factors, such as a times b, and the product equals 0, then we have two possibilities for this being true. Either a will be 0 or b will be 0. And this is exactly the situation we have here. We have either a is 0 or b is 0. In this case, our a from this illustration is x, and our b is 3x minus 5. Two things multiplied together, product equals 0. So either x will be 0 or 3x minus 5 equals 0. And of course, if 3x minus 5 equals 0, bringing the 5 over here, that means 3x is equal to 5, or x is equal to 5 divided by 3, or 5/3. So our two answers are 0 and 5/3. There you go, 0 and 5/3 for example number 7. Moving along now to example number 8. Example number 8. Example number 8 is similar, but a little exciting. Here we have a rectangle. So let's draw a rectangle. And we're told here that the width of our rectangle is x. So this is 90 degrees here. The width is x, and the length we don't know. We'll just name it L. What we can say, however, is that the area will be L times X. Now, it so happens that in this problem, they told us that the area is x cubed minus 2x squared plus 5x. And this, of course, is equal to our length times our width, L times x. And the question is, solve for L. Find L. What is L? Notice that this is L times x. If I could get this to be x times something, or something times x, the something that's multiplying x would be L. So let's see if we can factor out x here, which we can. We see there's an x in everything, so let's factor x out. X times x squared minus 2x plus 5, and that's equal to L times x. Notice that if x is being multiplied by L here, and it's equal to this, what x is multiplied by on the left must be L. So x times L, x times L, x times L, x times L. This is L. Or, if you like, the way you can show that now is just divide both sides by x. So x times x squared minus 2x plus 5 is equal to L times x. And let's divide both sides by x. The x's here cancel out. And I have that x squared minus 2x plus 5 is equal to L. So there's my answer for L. Okay, that is example number 8. Let's move ahead to see if we can find something more exciting. Let's do example number 9. Example number 9. Example number 9. So here we have a trinomial set equal to 0. So we have x squared plus 12x plus 32 equal to 0. Now let's factor this and see if we can get two factors, the product of which equals 0, then we could solve for x. So what are the factors here of x squared? It's 1x squared. So we know right off that our first terms, if we use FOIL, first, outer, inner, last, our first terms just are x and x. There is no other option, x times x, x squared, because it's 1x squared. However, factors of 32 could be slightly more complicated. Notice that 32 is the product of the last terms. This one times this one, the last. And we know that the outer plus the inner must be equal to the center term of 12x. So we're looking here for outer plus inner. So what are the factors of 32? Well, we can start off, we can say 32 is 32 times 1. Notice everything is plus in this trinomial. There are no negatives, so it's plus 12x plus 32. So these are both going to be positive. Our two factors are both going to be positive. Positive 32 times positive 1. And the outer plus the inner, that's going to be these two added together here. So 1 plus 32 is 33. Clearly, that doesn't work. We could also do 16 times 2. What's 16 plus 2? 18. It's not 12. Another option would be divide this by 2 and you get 8. 8 times 2 times 2, or 8 times 4. So we can have here 8 times 4. What is 8 plus 4? 8 plus 4 equals 12. So we're going to put an 8 here, we're going to put a 4 here, and we're going to put a plus and a plus. So here we're factored, and if the first term is 0, that means that x plus 8 would be 0, or x plus 4 would be equal to 0. In the first case, x would have to be negative 8. In the second case, x would have to be negative 4. So our answers now are negative 8 and negative 4. These are our two possibilities for x, negative 8 and negative 4. That's example number 9. Let's move to example number 10. Example number 10 is 40x squared plus 2x equals 24. To solve for this, we start off by bringing the 24 to the left. So we bring the 24 over to the left, and this then becomes 40x squared plus 2x minus 24 equals 0. In this case, we're concerned with two things. We now have to have, hold on, before we go farther, notice that this thing is divisible by 2. 2 is the greatest common factor of these three terms. We can factor the 2 out so we have smaller numbers to work with. So we can write this as 2 times 20x squared plus x minus 12. It just gets our numbers a little smaller, be slightly easier to work with. So we now need factors of 20, and we need the factors of negative 12. So when we think about the negative 12, how can we get a negative 12? Well, it's going to be a positive times a negative. It's going to be plus times a minus, or it's going to be minus times a plus. Okay? Positive times a negative, or a negative times a positive, would give us the negative 12. And because they are going to be opposite signs, the center term will be the difference between them, because when you bring a positive together and a negative together, okay, when you bring a positive and a negative together, they cancel each other out to some extent. They'll subtract from one another. The larger of the two, I'm talking magnitude now, distance from 0, absolute value, the larger of the two, negative or positive, will be positive because the center term is positive. Okay? So the larger of the two must be positive. Let's write down now the factors of 20. We can write down 20 times 1. We can write down the next one will be 10 times 2. And then we could have 5 times 4. And that would be it, because the next one would have to go down to 1 times 20, and we don't have to reverse the first ones here. We just reverse on this side. What are the factors of negative 12? Well, we can have 12 times 1. Okay, what's the next factor of 12? We can have 6 times 2. Okay, bringing down a little bit more, we can have 4 times 3. Or we could have 2 times 6, or we can have 1 times 12. Okay. So now let's think. Oh, I forgot. It's 4 times 3, or the next one is 3 times 4. I forgot to put 3 times 4 in there. It should have been right here, 3 times 4. So here are my options. And let's look for the outer and the inner. Now notice these are the first terms. They will go right here. You'll have your first terms being these two numbers. The last terms will be these two. And then the outer and the inner is going to be like 20 times 1, subtract 12. 20 and 12 has a difference of 8. I'm looking for a difference of 1. 10 and 2 is 20. 2 and 6 is 12. 20 and 12, again, has a difference of 8. That's not it either. Okay? How about this one? 30 and 12. No, that's not going to work. In fact, it gets worse as I go down because these numbers are getting bigger. So I have to jump to the 5. 5 times 1 is 5. 4 times 12 is 48. So difference between 5 and 48 is 43. That doesn't work. How about this one? 5 times 2 is 10. 6 times 4 is 24. Difference of 10 and 24 is 14. That doesn't work. Remember, I'm looking for a difference of 1x, 1. So how about this one? 5 times 3 is 15, and 4 times 4 is 16. Aha! Look at that. 5 times 3, 15. 4 times 4, 16. These are our guys right here. These will work right here. So it's 5x and 4x right here. 5x and 4x. Remember, these are our first terms. Okay, 5x and 4x. And then I look at the 4 and 3, and I put them in that order, 4 and 3. And now you ask yourself, remember, one has to be positive, one has to be negative. So which one will take the positive sign? Because the center is positive, right? The larger of the two will take the positive sign from the center. The larger of the two. So here we have 15. 3 times 5 is 15x. And 4 times 4x is 16x. So 16x is bigger. This must be a positive here. So that positive 4 times positive 4x will be positive 16x. And then I will be adding to that a negative 15x, or subtracting 15x, which will give us the positive 1x. So here we have our factored expression. So we have 5x plus 4 equals 0, or 4x minus 3 equals 0. In the first case, if this one is 0, 5x equals negative 4. And if you divide both sides by 5, you get x is equal to negative 4/5. In this case, 4x would be equal to 3, or x is equal to 3 divided by 4. So negative 4/5. The negative sign really should be in front here. And 3/4. These are our answers. That is example number 10. Let's move to example number 11. Making good progress here. I hope this is helping and that you'll be ready for the test coming up. I urge you to watch this video a couple of times. Make sure you're prepared. So let's move to example number 11. Example 11. Six x squared minus 7x minus 5 equals 0. Okay? Solve for x. Well, here again, the way to do it is to factor this expression. So we look for factors of 6, and we look for factors of negative 5. Again, negative 5 can only be gotten by taking negative 1 times 5 or positive 1 times negative 5. Okay? Or let me just write them down. I think I got myself mixed up. Here we go. So what are the factors of 5? It's 5 times 1 or 1 times 5. Okay? And of course the signs have to be different. It's either positive negative or negative positive or positive negative or negative positive. Anyway, the signs of these two would have to be different. What are the factors of 6? We have 6 times 1. We have 3 times 2, like that. Okay? Now let's look here and ask ourselves, the center term is negative 7. Okay? So the larger the outer and the inner must take a negative sign. Must take a negative sign. So this is either going to be plus and minus or minus and plus. So let's look now. Outer, 6 times 1, 6. 5 times 1 is 5. The difference of 6 and 5 is 1, not negative 7. How about this one? 6 times 5 is what? 30 and 1. The difference of 30 and 1 is 29. That doesn't work. How about 3 times 1 and 2 times 5? 3 times 1 is 3. 2 times 5 is 10. The difference between 3 and 10 is in fact 7. Okay? So our outer, 3 times 1, inner, 2 times 5. So this is it. These guys are right here, work for us. So we put 3x, 3x and 2x, and then we put 5 and 1. And then you ask yourself, okay, which should take the negative sign? The larger of the two, because the center term is negative. So we look at 3 times 1 and 2 times 5. Which is bigger, 3 times 1 or 2 times 5? 3 times 1 or 2 times 5? 2 times 5 is bigger. It must have the minus sign. So we make this negative 5 times 2x. And this would be 3x times 1, so I put a plus here. Here we have it, two factors multiplied together, giving us a product of 0. That means that 3x minus 5 equals 0, or 2x plus 1 equals 0. In the first case, 3x would be equal to 5, or x would be 5 divided by 3. In the second case, take the 1 over to the other side. 2x would be equal to negative 1, or x would be equal to negative 1 divided by 2. So my answers would be negative 1/2 or 5/3. It's example 11. Let's move to example number 12. 9x squared plus 5 equals 30. Example number 12. 9x squared plus 5 equals 30. Okay, solve for x. Well, to begin with, let's just move our 30 over to the left so we have it set equal to 0. So this becomes 9x squared, bringing the 30 over here, plus 5 minus 30 is minus 25 equals 0. So bringing the 30 over, 5 subtract 30 is negative 25. Now, as you study this, I hope you recognize that 25 is a perfect square. It's 5 squared. And 9 is also a perfect square of 3. 3 squared is 9. So we see here then that this can be written as 3x quantity squared, subtract 5 squared equals 0. Remember our rule, difference of two squares, a squared minus b squared. How does it factor? A squared minus b squared was a plus b times a minus b. So here's my a and here's my b. This thing will factor as 3x plus 5 times 3x minus 5. Okay. If the first term is 0, by the way, you can check yourself. 3x times 3x, 9x squared. Minus 15x plus 15x. Minus 15x, outer, plus 15x, inner. They cancel. And then the last is minus 25. It checks out. So now either 3x plus 5 equals 0, or 3x minus 5 equals 0. If the first term is 0, 3x will be equal to negative 5. Sorry about that. 3x will be equal to negative 5, or x will be equal to negative 5 divided by 3. How about the second case? 3x is equal to 5, bringing the 5 across here. X is equal to the very same thing. Okay? Or not the very same thing, excuse me. I was thinking of something different. 3x equals 5, or x is equal to 5 divided by 3. Same but opposite sign, okay? Same but opposite sign. So again, this term equal to 0, bring your 5 across, it's negative 5. Negative 5 divided by 3 is negative 5/3. So here are our two answers. Negative 5/3 or 5/3. These are the two possibilities for this one. Example number 12. Moving ahead, example number 13. Example number 13. X minus 5, quantity squared, equals 64. How about this one? Again, bring the 64 to the left, set it equal to 0, solve for x. X minus 5, quantity squared, minus 64 equals 0. Notice now that 64 is 8 squared, so I have x minus 5, quantity squared, minus 8 squared equals 0. Now, difference of two squares, a squared minus b squared. Never mind that a, in this case, is x minus 5. It does not matter. This is a, this is b. A squared minus b squared. Just factor it. A plus b times a minus b. Difference of two squares. A plus b is x minus 5. That's a. Plus b plus 8 times a minus b, which is x minus 5 minus 8. Those two things equal, the product equals 0. What is x minus 5 plus 8? Okay, this would be x plus 3. And x minus 5 minus 8 is x minus 13. Product equals 0. That means that either x plus 3 equals 0, or x minus 13 equals 0. In the first case, x will be negative 3. In the second case, x is equal to 13. So I have negative 3, 13. These are the answers. Okay. I just want to point out that if I have something that looks like this, watch this for a minute here. If I have something that looks like this, what if I had x squared equals 25? You know that if something squared equals 25, the thing that we're squaring would have to be the square root of 25, or 5. So if I take the square root of the left and the square root of the right, then I get rid of the square here. The square root of x squared is just x. And the square root of 25 is 5. However, if you remember in class, I showed you that when you take the square root of something like this in equation form, we are talking about more than the principal square root. We want both roots. So this will be plus or minus, plus or minus. The same thing would apply here in this problem. I have something squared equals 64. If I take the square root of the left and the square root of the right, I will have what's inside the parentheses. Take the square root of x minus 5 squared. Okay, the square root of this quantity will be just x minus 5. So if I were to do that, I'm going to move on down now and show you down, well, here, let me do it over here. Let us go ahead and say x minus 5 quantity squared is equal to 64. If I do the square root of these guys, it'll have to be plus or minus. All right, that's getting a little messed up there. Plus or minus. So this will be x minus 5 is equal to plus or minus the square root of 64, which is plus or minus 8. Okay? And that means that x will be equal to 5 plus or minus 8. Interesting. What is 5 plus 8? 13. Or what is 5 minus 8? Negative 3. Notice these answers here are exactly what we had using factoring. So again, if I took the square root right here, square root of the left, square root of the right, it's x minus 5 equals plus or minus the square root of 64. Take the square root of the left, square root of the right, but don't forget to put plus or minus like we did here. Plus or minus, okay? Example 13 has some concepts there that are important, and I hope you catch those and understand. Let's move now to example number 14. We're getting down toward the end here. Example number 14. What if I have 4x to the fourth minus 1 equals 0? Example 14. 4x to the fourth minus 1 equals 0. Notice that this can be written as the difference of two squares. What's the square root of 4x to the fourth? Well, the square root of 4 is 2. The square root of x to the fourth is x squared. So this will be 2x squared quantity squared minus, and the square root of 1 is just 1 squared. Sorry, the 1 can be written as 1 squared. 1 can be written as 1 squared. 1 squared is 1. So here now I have the difference. I'm subtracting 2 squares. 2 squares. Notice what's in the first parentheses. That's my first square. And then 1 is the second square. And of course equal to 0. So let's factor. You know how to factor this. A squared minus b squared factors as a plus b times a minus b. So a in this case is 2x squared. So this becomes 2x squared plus 1 times 2x squared minus 1. Okay? Product equal to 0. Okay? So that means then that either of these two guys could be 0. In the first case, what if 2x squared plus 1 were equal to 0? Take the 1 to the right, and I get 2x squared is equal to negative 1. And if I divide both sides by 2, I get x squared is equal to negative 1/2. I want you to think for a little bit. What number squared could give you a negative 1/2? Or, pulling you a little closer to the point, forget the half. What number squared could give you a negative? Can you ever square something and get a negative? No. At this point in your mathematical experience, you don't know how to take the square root of a negative number. And it takes us to a realm called imaginary numbers, which we're not dealing with in Algebra 1. But there is no principal square root for a negative number. Therefore, this one, we say there is no solution, because you can't have a negative square, something squared giving a negative answer. In the second case, however, we can do something. 2x squared minus 1 could be 0, or 2x squared equals 1, or x squared equals 1/2, or x is equal to plus or minus the square root of a half. Okay? X is equal to plus or minus the square root of a half. This takes us just a little farther than what you may remember, or actually, no, you wouldn't remember, because this is actually in Algebra 2. Simplifying radicals. We might do this in chapter 10, I believe it is. But for right now, this thing could be written as follows. Notice I can write it as square root of 1, this is plus or minus, divided by the square root of 2. And then if I multiply top and bottom by the square root of 2, square root of 1, by the way, in the numerator is just 1. I have square root of 2 in the denominator. If I multiply this by the number 1, written as the square root of 2 over the square root of 2, notice in the numerator, 1 times square root of 2, 1 times the square root of 2 in the numerator is just the square root of 2. In the denominator, square root of 2 times square root of 2 is 2. Now, don't worry too much about this. I won't put one of these on the test because we haven't really covered this, but it's a sneak preview of things to come. You do not have your answer in simplified form so long as you have a square root in the denominator. So if you take the square root of 1/2, this is square root of 1 over square root of 2. Square root of 2 is in the denominator. That is not simplified. So this is not simplified. The way you get rid of it is multiplied by the number 1, like this. And notice that it's square root of 2 over square root of 2. And that gets rid of the radical in the denominator because square root of 2 times square root of 2 is just 2. So it ends up being root 2, the square root of 2 over 2, plus or minus square root of 2 over 2. Okay, that's kind of cool. We could see that in a different way by writing this as the difference of two squares. Notice that this could be the square root of 2x quantity squared minus 1 squared. And we could factor it like that and solve and get the answer as well. But I think I've belabored this point enough. Let me leave this problem. This is a little complicated and probably is doing more to confuse you than to help you at this point, I'm guessing. So this is not coming on the test, but it's still a good problem. Okay, let's move ahead to example number 15. Example 15. Example number 15 is 16n squared plus 40n plus 25 equals 9. Okay? Solve for n. First thing we would like to do is to bring the 9 over here. Bring the 9 over here. Okay? So this will become 16n squared plus 40n. Now let's think. 25 minus 9. 25 subtract the 9 will be 16 equal 0. Let's factor a 2. No, let's factor an 8 out of all of this. Okay? An 8. So we'll write an 8 out front. 8 times 2n squared. 8 times 5 is 40. 5n. 8 times 5n is 40n. Plus 8 times 2 gives 16. Let's factor this guy now, if we can. This one's kind of easy because you can't get 2n squared except you take 2n times n. And 5, again, is a very small number, so we don't really have to go through the whole outer plus inner thing over here finding all the factors, because there aren't very many choices. How do you get 2? It's 1 times 2 or 2 times 1. So let's think. If it's 1 times 2, 2 times 2 would be 4, plus 1 would be 5. So that's it right there. We take 1, we put 2. And everything's positive, so we put plus plus. So notice 2 times 2n, 2n times 2. That's 4n. Plus 1 times n is n. 4n plus 1n is 5n. And 1 times 2 is 2. So this equals 0. So 2n plus 1 equals 0. Or n plus 2 equals 0. In the first case, 2n equals negative 1. Or n is equal to negative 1/2. Okay? In the second case, n is just negative 2. Take the 2 to the other side. So my answers will be negative 1/2 and negative 2. So there you have example number 15. We've got one to go. Yeah, example number 16. I think we'll end with this one. One last example. Example 16. Nine y squared minus 12y plus 4 equals 0. Okay? Here we need to go through our possible factors. So we look at factors of 9, and we look at factors of 4. Now notice that 4, it's positive 4, right? How can you get a positive? Well, you can take a positive times a positive, or you can take a negative times a negative. In either case, you'll get a positive 4. Our center term is negative. If everything was positive, we would not have a negative. So we have to choose the minus minus option. Okay, I hope that makes sense to you. We have to choose the minus minus option in order to get a negative center term. The outer plus the inner will add together, and they're both negative, so we have to get negative 12 out of that. So what are the factors of 9? Well, 9 times 1, 3 times 3. Okay. What are the factors of 4? 4 times 1, 2 times 2, or 1 times 4. Outer plus inner must be negative 12. Remember, these are both going to be negative. Okay, so it's going to be negative 9 plus negative 4 would be negative 13. Again, 9 times 1 is 9, 4 times 1 is 4, 9 and 4 is 13. That doesn't work. How about this one? 9 and 2, 9 times 2 is 18, and 2 is 20. That's worse. And then this is 9 times 4 is 36. That even gets bigger, gets farther away from 12. So I know I'm going to be going with the 3 and the 3, if it factors, all right? What's 3 times 1? 3. And what's 3 times 4? 12. Okay, 3 and 12 is 15. That doesn't work. How about this one? 3 times 2 is 6, and 2 times 3 is 6. 6 and 6, 12. Aha. Here's our answer. Right here, these are the ones we'll be using. So let's make our 2 parentheses. Okay. And we put 3y and 3y. It gives us 3y, or 9y squared. And then I put 2 and 2. And it's minus, minus. Okay. Notice that this thing is a squared minus 2ab plus b squared. It's a plus b, or a minus b quantity squared. It's of that form. So so let's go ahead and solve for this. 3y minus 2 equals 0, or same thing, right? 3y minus 2 equals 0. They're exactly the same, so there's only going to be one possible answer here. So we have 3y is equal to 2, or y equals 2/3. And you'll get the same thing over here, y equals 2/3. So this is your answer. Okay, so that is example number 16. Well, class, so that's quite a few examples. I know this was a bit of a long lecture, but hopefully if you watch it in parts, watch a little bit of it, stop, watch a little bit of it, stop. Hopefully if you go through it carefully, you'll be in good shape for this test. If you have any questions in Moodle, you can use the little chat feature up there by your name. There's a message little blurb. You can click on that and you can send messages, and hopefully you'll be able to contact me in that manner and get any questions answered if you have some. Or you can reach out to each other and get questions answered. So God bless you guys. I hope you do really well on your test. I'm going to let you work on this today. And I might give you one little quiz in prep, and then we'll take the test. So study hard, give it your best.